Good morning. In this video, I'm going to go over combining like terms, and I'm going to talk a bit about the assignment from last class. I'm going to go through some examples from that. So we're going to discuss what terms are. When we say the word terms, what does that mean? I know we've heard this before, but we're going to go over that. What are like terms, how we can identify what's a like term and what isn't. And we're going to go through some examples from the Google form and MathSpace. Okay, let's get started. So first we want a definition of term. And I'm going to give you the definition, then we're going to discuss what exactly I mean by that. And so the definition I like is that a term is a single number or variable. So when you think of 5, 7, or x, that's considered a term. Or numbers and variables multiplied by each other. Okay? So again, like I said, if I just have 5 plus 4, 5 is a term and 4 is a term. If I have 5 times 4, then they're both just one term. So this is 2 terms, this is 1 term. Okay? So only addition and subtraction signs separate terms. So 5 minus 4 would also be 2 terms. Okay? Let's look at these examples. So when I say 5p, it's not a single number. So this first part of the definition applies only to very simple things like what I showed here. Okay? The second part, numbers and variables multiplied together. This is what we're going to be focused on mostly. So 5p just means 5 times p, right? So this is multiplication, which means that this expression right here, has just one term. Why? Because there's no addition or subtraction. Like I said, only, and I want you to write this down, only addition and subtraction separate terms. Okay? So let's look at the next one. 3x plus 4. We can see that there's an addition sign here. And so we know that 3x and 4 are different terms. So in this case, we have 2 terms. We have 3x here, but again, this is just multiplication, 3 times x. And so it's counted as 1 term. All right? Here we have 9m minus n. So notice that these are different. So I'm just going to put one line here. I'm going to put 2 lines here just to show that they're different. And 7xy. So I'm going to put 3 lines here. Underneath the whole term, actually. Okay? So there are 3 different terms in this case. 2 terms. So 9m, this is 1 term. And then we see a subtraction sign. So right away we know that this is a different term. Then we have n, or negative n, that's a whole term. And then we have 7xy. Even though it has 2 variables, this is just 7 times x times y. So they're all being multiplied together. It doesn't matter, they're still 1 term. Okay? Now if I have a fraction, let's make just one more example here. If I have, let's say 7x over 4y. Again, all of this is 1 term. Why? Because it's not separated by addition or subtraction. They have to be number and variables multiplied. Let me add in the definition, or divided. So this definition needs tweaking. Or divided. Okay, let's move on. What are like terms now? So we know what terms are, but what are like terms? And if you just think of like just the word like, there are terms that are alike. How are they alike? Well, like terms, there's a definition of it, right, are terms that have the same variables and powers. Variables and powers. So we need to look for 2 things. Variables and powers. The powers that are on the variables, that is. Not just on the numbers. So this is the power, for example, if you don't know what I'm talking about. So sometimes it's called power. Sometimes it's called exponent. We're not going to be talking about it much. I just wanted to make sure that you knew this. But let's look here in the first example. 6x plus 3 plus 2x. Okay? We have three terms, right? Three terms. And the first one is 6x. Now, are there any other terms out of these that have the same variables and powers? So 3 doesn't have an x, so 3 is an unlike term. So I'm going to put 2 lines under it. And then the 2x has an x, so x and x, that's good, even though the coefficients are different. So the 6 and the 2 are different. But as long as the variable, the x, and the power of that variable, so the power here, if there's nothing, that means that the power is 1. So they both don't have a power, which means that they're the same. Then these two are like terms. So in this case, we can add them. So the thing about like terms is that you can't add or subtract unlike terms. But since these are like terms, we can say 6x plus 2x, which would be 8x. And then the 3 would just remain as it is, so plus 3. Okay? In the next example, we have 5y minus 7xy. So I see a y here and I see a y here. But there's an x. And this x is not present in the first term. And so these are unlike terms. So I'm going to say 2 unlike terms in this case. So we can't do anything. If you can't simplify it any more than how it is right now. So it stays as it is. In the last one, we have 5. We have 9x. We have negative 2. And we have 3x squared, 3x to the power of 2. So 5 has no variables next to it, and the only thing like that is the negative 2. So 5 and negative 2 are like terms, okay? We have 4 terms total here. Then the 9x, I'm going to put 2 lines underneath it to differentiate it. The 3 has an x, but this x has a power, and so they're not the same. So for the 3, I'm going to put 3 lines underneath it, just to say that it's not the same. So if we simplify this, 5 and negative 2, if we combine them, it makes 3, plus 9x plus 3x squared. We can't simplify anymore. Okay? Now, let's look at some examples from our last assignment. So let's look at number 13 and number 14. Number 13 says, simplify the expression 8x 6y plus 6y minus 2y minus 4x. Okay? So we have 4 terms here, as you can see. I'm going to mark the like terms with a line. So 8x, the only thing like the 8x here is there's a y, there's a negative 4x. So those are the same. And then moving on to the 6y, the only thing like it is the negative 2y. So I can combine the 2 red ones, and I can combine the 2 blue terms. So 8x minus 4x would just be 4x. And then 6y minus 2y would just be positive 4y. So notice that 6y minus 2y, we have to write the sign of the result. So positive 4y. So this is it. This is our answer. I want to go as well to the Google form and talk a little bit about some of the tougher questions here and how to review how to translate it to an expression. Okay? So let's do the last 2. In number 7, it said, Ansari won 5,000 pounds in a gaming competition. He then started saving 2,000 pounds every year for X years. How many thousand pounds does Ansari have now? So he started with 5 because he won 5. And then he's saving 2,000 pounds every year. So he's adding 2 multiplied by the number of years. So let's say if he saved for 3 years and 2,000 pounds each time, so he would do 2 times 3, right? But it said here X years. And so we're going to say 5 plus 2X. This is the expression that we want. There's nothing to simplify here, but I just want you to know that this is the answer. In number 8, it says Yahya scored 3 goals every game for X games. So every game he scored 3 goals, and he played X games. So again, we're multiplying, right? So it's 3X. This is the number of goals he scored. It then says he then scored 4 goals in his last game. So he played X games. He scored 3 goals every game. So we already have this with this expression. And then added onto that, he scored 4 goals. So we are able to come up with this expression here. All right. If you find this confusing, please let me know so we can work together. Still very few are reaching out to me to get tutoring, and I need more of you to reach out so we can work through assignments together. For today's assignment, we're going to be combining like terms again, but this time it's going to involve fractions and decimals. So if you need to brush up on fraction addition and subtraction or decimal addition and subtraction, please make sure to go back to the old assignments and the old videos to review. Okay? Good luck. If you have any questions, please email me so that we can set up Zoom, or just show me screenshots of what you're working on, and I'll try to answer over email if I can. Okay? I'll see you on Zoom. Bye.